Right now, sir, total 101 has entered into the meeting.
Okay.
We have 200 participants. So I think they will join within a
Okay.
short time. So we'll start the annual ceremony because it is already 10. Uh,
Mm.
so Aditya, you can start, please.
Yes, sir. I hope I am audible, sir.
Yes, you are.
Yes.
Thank you. So, hello everyone. Namaste. A very pleasant morning to one and all present, esteemed dignitaries, the head of departments of this very institution, and of course, all participants. I, Aditya Pal, on behalf of the Applied Mechanics Department, LD College of Engineering, wholeheartedly welcome you all in this intellectual and interactive 5 days faculty development program on advances on earthquake safe design and construction practice conducted under AICTE Training and Learning Academy. Now, before moving forward, as what our the great Indian culture teaches us, we shall begin this auspicious event by revoking and evoking the goddess Saraswati and through a very sweet and short prayer.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता क्षमा पातु सरस्वती भगवती विशेषजाड्यापहा
That was short, but I believe that those chants have filled this environment with devotion and charisma. So, without taking any much time, I would be feeling honored to introduce you all with our revered personalities we are having today with us. We have Honorable Professor C.R. Murthy, who is Assistant Chair Professor, Department of Civil Engineering, IIT Madras. Further, we are having Professor P. Provost and Vice Chancellor of Pharmacy University, Nagpur. He is the peer reviewer of this. Java is a member of Executive Council of Commonwealth University in London. I welcome you on behalf of the Applied Mechanics Department. Moreover, we are fortunate to have Dr. Rajan Sajjar ma'am with us, Principal LD College of Engineering, and who is also the chief patron of this faculty program. We are also having Major Dr. Sangvi, sir, the head of Applied Mechanics. He is also the coordinator of this activity. We will be hearing from all these dignitaries in a very short while. But before that, as this program is conducted by the Applied Mechanics Department of LD College, I would like to grab this opportunity to speak something about my college and department. LDC, the Lal Bhai Dattacharya College of Engineering, is a premier government engineering institute in Gujarat state, set with the objective of imparting higher research and training in various fields of engineering and technology. Now, LD College of Engineering was established in the year 1948. It's one of the very few first engineering colleges in India. I think you can connect some of the resemblance with the year I intentionally made 1948 because we can see where India is now completing. India has completed 70 years of its independence. Coincidentally, LDC is also entering in its 75th year of successfully imparting technical education to the aspiring engineers. LD College of Engineering offers both undergraduate and postgraduate courses in as much as 14 major departments. To add more feathers, LDC has received the prestigious NDA accreditation grant for 5 different departments. LDC is now proudly the only five-star institute in Gujarat and nationally proclaimed as the outstanding engineering institute. Being such a historic institution, LDC is not only about the great past legacy, but very actively upgrading system and infrastructure as per the need of modern technical education under the dynamic leadership and teamwork of all the stakeholders. Moreover, the Department of Applied Mechanics is a vital shoot of civil engineering in this very campus of Applied Mechanics. Applied Mechanics deals with imparting education to the undergraduate students, including the subjects like mechanics of solids, geotechnical engineering, design of structures, concrete technology, retrofitting of structures, and earthquake engineering. Moreover, this department also offers two postgraduate courses in structural engineering since 1986 and geotechnical engineering since 2010. Above the regular classroom teaching, Applied Mechanics department has also been involved in research and consultancy. We have collaboration with the major firms pan India for testing and research purposes. Now, I would be pleased to invite Major Dr. C.S. Sanghvi sir, the head of Department Applied Mechanics and the coordinator of this FTP program, to deliver the welcome address. Over to you, sir.
Uh, yeah, am I audible?
Yes.
Yeah. Very good morning to one and all. Respected Dr. C.V.R. Murthy sir, the Institute Chair Professor at IIT Madras, and he is the chief guest of this inaugural function. Dr. Sandeep Sancheti is the Vice Chancellor of Marwadi University, reviewer of this Atal FTP. Dr. A.K. Gajjar, Principal, LD College of Engineering, and the Chief Patron of this FTP. All head of the departments, faculty members, dear participants, and volunteers. It is my pleasure to welcome you all on behalf of Applied Mechanics Department of LD College of Engineering, Ahmedabad. In Government Engineering College of Gujarat, civil engineering program is shared by the two departments, namely Applied Mechanics and Civil Engineering. Applied Mechanics Department of LD is very proactive in the area of earthquake engineering. Department has developed a very unique low-cost instructional earthquake engineering lab set up with the help of the GSDMA, Gujarat State Disaster Management Authority. Now, the cost of this setup is only 7 lakh rupees, and institute is considered as a resource institute in the area of earthquake engineering. It has carried out a project of library and laboratory development in this area with the help of the GSDMA. Now, in Gujarat, almost 50 institutions have developed a similar laboratory setup in their institute. Department has coordinated more than 60 training programs with GSDMA, GIDM, Road and Building Department in last 15 years for the government engineers, professional engineers, architects, admin officers, masons. Department is also preparing the 18-episode series on earthquake resistant construction for the civil engineering professionals with the Education Multimedia Research Center. And already 6 episodes are telecast on DD National Network. Department has also developed learning resources on seismology, RCC, and masonry structures with the help of the PDDC students. Basically, department has completed a project of development of shake table and models with Gujarat Council of Science and Technology, GUJCOST. Department has coordinated unique national level model testing competition, the tremor terror in the area of earthquake engineering for the students for at least last 10 years. Recently, during the Corona pandemic, department has developed a low-cost actuator with 50-ton capacity and the biaxial shake table with the 2-ton capacity, payload capacity. The cost of this product is less than 20 lakh. If you look at in the market, it costs maybe more than 60 lakhs or 80 lakhs. Department is continuously working in this area. Now, I want to tell you that Applied Mechanics Department has organized a Atal FDP on earthquake safe design and construction practice in December 2020. Now, this is the advanced version. This training program is the advanced version of the that Atal FDP. Now, you can also say that it is a season 2 of the earlier program. Now, question will arise: why this FDP on advances in earthquake safe design and construction practice requires? We know that India is prone to severe earthquakes. We have seen many earthquakes at regular interval of 3 to 5 years from 1988. अब 1988 से आप देखना तो we have earthquake in Bihar, Nepal, 91 Uttarkashi, we have 93 in Latur, 97 Jabalpur, 2001 Bhuj, 2005 Kashmir, 11 Sikkim, 2015 Nepal. India has observed 5 great earthquakes in past. But the most important observation is that after 1950 Assam earthquake, India has not observed any earthquake. It means lot of energy had been stored, which may bring a big earthquakes in future. And over the years, we have seen that these earthquakes have caused extensive damage to the life and property and have adversely impacted the economical development. And therefore, we should have a proactive, a comprehensive, and sustained approach to reduce the detrimental effect on overall socio-economical development of the nation. We know that earthquakes do not kill people, but unsafe buildings do. So right now, if you look at the scenario of India, infrastructure of India is growing at a rapid pace, record speed. Only the development of infrastructure is not important, but the safe infrastructure is more important. We have to apply the advancement taken place in the field of earthquake engineering to the real life structure. And therefore, the technical fraternity has to ensure earthquake safe design and construction practice in the hazardous zone of the country. It is a long-term process that involves a capacity building in this area. If I mention the case of America, USA has started the capacity building program in 1970, and it is still going on. We haven't started yet. Just imagine how much time we need to reach the similar level of preparedness. Earthquake engineering is not remained as a core subject in the curriculum of UG civil engineering courses, and therefore there exists a need to train the faculty members effectively in this area for the benefit of the students. This program will improve the capacity building process in the area of earthquake engineering. For this program, we have invited experts of national and international repute. These experts have worked at ground level and they are aware of the ground reality. Various relevant topics are covered in the schedule. I am sure you will enjoy this FTP and you will contribute in the capacity building process in future. Thank you very much to all the experts, participants, volunteering faculty members and students. Jai Hind. Thank you. You can continue, please.
Thank you so much, sir. This clearly depicts the grandeur of the college as well as the department which has been set up after the sheer hard work of all the faculty members. Now, moving ahead, I will be obliged to welcome Dr. Rajul K. Kacharman, College of Engineering and Chief Patron of this. I will take a small moment to introduce to all of you. Ma'am has a colossal experience of 39 years in the engineering profession. Ma'am completed her undergraduation and post-graduation from LD College of Engineering, Ahmedabad, and her PhD from MS University, Baroda. Ma'am has published numerous national and international research papers along with several published patents named after hers. Ma'am has authored various books and has supervised more than 30 postgraduates and 8 doctoral students. Among the major national awards, Ma'am has been bestowed with Eminent Civil Engineer for Outstanding Contribution to Engineering by Honorable Chief Minister of Gujarat, for Best Innovation Practices by Honorable HRD Minister at International Vibrant Education Summit by NASCOM and Higher Education for Leadership. Ma'am has led more than 38 high-end projects on international collaborations, Center of Excellence, research innovations, accreditation, and ranking frameworks for excellence in engineering education, industry, and alumni outreach, internships, faculties, and student outcomes. And possibly I will get tired to continue the list, but the ma'am.
In fact, I was just going to tell you, let's move on. Let's move on.
Yeah,
Thank
ma'am
you.
will keep on adding more feathers to our list and
Please,
those
please,
accolades
please.
to her name. It has truly been a bliss for students like me to study under her guidance and leadership in this college.
Thank you so much for the kind words. Basically, I'll take it up from here. Am I audible? Yeah, okay, fine. So basically, there are 2 points that I would continue from Dr. Sangvi's introduction and talk. Number one, the entire setup of the earthquake laboratory, the entire ecosystem that we have been fortunate enough to be the nodal center for across the state, has been under the huge motivation and guidance of experts like Dr. Murthy. He was one of the pioneers who has helped us create these facilities, and like setting up these indigenous shake tables was not an easy task. We have to calibrate them, we have to bring it up. I remember in those days we were like in awe of what I see Bangalore was doing, and they were the first ones to get them. And then when we heard the amount that they would spend and the challenges that we faced, and we brought in the fabricators, and Dr. Murthy would be there personally, physically guiding us, do this, make those changes, is how I don't even know where to start. Should we call it the small scale interventions making such a deep impact, or the biggest impact that any state or nation should learn from, are the examples. So thank you very much, Dr. Murthy. With Dr. Sancheti has been, I don't know if he remembers, but on and off we have met quite frequently. So thank you once again for sparing your time and being with us. And that was something that I wanted to fill in from what Dr. Sangvi had mentioned. There's one another point that I would bring to this platform, is that LD has been reinventing itself, and it has carried a huge legacy of academic excellence, and we built up on that, and we are very happy that all the students' projects, all the research by the faculty, all these innovations, these interventions that we have brought into the education system in terms of the learning experiences have put us at rank third in the country after COEP and VJIT in innovation ecosystem. So that also puts a bigger responsibility on our shoulders to carry on this legacy and keep on doing the good work in terms of the innovation and research that we are doing at LD. So this was an add-on to what I meant to say. I had given myself a very short time because we want to listen to the experts. But so very quickly, I'll wind up in terms of the initial talk that I had with Dr. Murthy. If maybe you heard the two of us talking, it was about the 5-year program being turned into a 4-year program, and so it's a huge dilemma about the entire education system, that we have to unpack all the stuff that really needs to go into the curriculum. And as Dr. Sangvi has mentioned about the core, like internationally, while you are designing the curriculum, there has been pressure to reduce the core, keep it very strictly to the extremely basic essentials, keep on adding more electives, and that is where like the whole balancing act comes in. But at the core of it all, while we were doing the civil engineering curriculum, this was the whole idea that we held on to, that earthquake engineering as a science, as a civil engineering concern, as a curriculum, has to be imbibed into everything that we teach. So it can be management, if you want to give just the very basics. It can be in the entire portfolio of all the subjects that applied mechanics deals with. Not just applied mechanics, wherever there are these two departments, civil as well as applied, the force that we put ourselves into this was that every teacher who teaches civil engineering should be very well equipped with everything that they need to know. Maybe it is not there as a separate subject, but everything that has to be known to a teacher has to be given in terms of these FDPs. That is why we hold these FDPs very, very, very closely to our heart. Because only when you come from this deep knowledge are you able to unpack that knowledge in terms of all the subjects, all the structures that you deal with, and that is how you can internalize and make this this whole concern, the severity aspect of these forces that we are dealing with, into our daily life as engineers. So that is the importance we give to this FDP. I hope that everyone who has registered, all the students, all the teachers, take it in that context. Packing it in just 5 days is a tough task, and therefore you have to, like I call it, that's my personal linguistics that I have developed, is zoning in. You have to completely zone yourself into this FDP. Maybe there are other things going on all around you, so many aspects that you are dealing with, but this is where you have to put all your focus, because I will also talk about the SDG, the Sustainable Development Goals, in terms of education. And this is where we can pitch in. This is where we have to bring into the sustainability aspect also. You cannot just say that you design a structure, you make it economical, you can do this. But what happens, as we have said, that all these forces inside of the whole crust are building up. And then all of a sudden, when there is a big hit, everything goes haywire. And so this is what we have to factor in. We are very, very thankful that the experts have agreed. Thank you so much, Dr. Murthy, Dr. Sancheti, all the experts, and wish you best of luck to all the participants to get as much as you can, make it as interactive as you can, because we depend on you to spread out this word, to make each and every student at the grassroots level understand and know the responsibility that they carry in terms of being sensitive to the earthquake forces, not take them lightly, not bow down to the pressures of the industry while they are working as professionals. Thank you so much. Thank you. Over to you, Abhishek.
Thank you so much, ma'am. Those words literally summarizes the crux of organizing this FDP program, and must have definitely motivated all the participants attending this FDP. Now, moving further, of all the dignitaries, I would wholeheartedly like to welcome our today's guest of honor, Dr. CVR Murthy sir. It is my sheer privilege to introduce such a renowned and decorated personality. Dr. CVR Murthy sir, he is an institute chairman of the Department of Engineering, Indian Institute of Technology, Madras. Dr. Murthy received BTech in Civil Engineering degree and MTech in Civil Engineering degree with specialization in structural engineering from Indian Institute of Technology, Madras itself, and PhD degree with a specialization in earthquake engineering from California Institute of Technology, Pasadena, USA. There is primary R&D interest in nonlinear earthquake behavior of buildings and bridges towards developing displacement-based and energy-based earthquake-resistant design. Sir has authored and co-authored 6 books on earthquake-resistant design and construction. Sir has been associated closely with the National Disaster Management Authority, that is NDMA, the Government of India, to prepare guidelines and implementation strategies. Currently, Sir is a member of National Advisory Committee of NDMA. Also, Sir is the chairman of Earthquake Engineering Committee of Bureau of Indian Standards and steering comprehensive upgrade of earthquake design standards in India. Sir is a fellow of Indian National Academy of Engineering and Institution of Engineers in India, and whatnot. I might need a separate session if I wish to complete the paper I am holding with all his achievements, and not to mention which I have prepared after making it as short as possible. So I won't take much time. Without any further ado, I want to request Professor Dr. C.V.R. Murthy sir to grace us with his kind words. Thank you, sir. Please, over to you.
Thank you, Professor Rajul Gajjar, Principal of LD College, Professor C.S. Sangvi, Head of Civil Engineering, dear participants, ladies and gentlemen. This is a very special invitation that I received from LD College, and I'm always ready for anything that Colonel Saab tells me. Goli maro to, we will be there for him on the fronts and take it on the chest. So our affection and respect for each other has grown over the last 2 decades, and the vision of Madam Rajul Gajjar has finally borne fruits, and we can say that you are a standing example of what a college should be doing with time and with the commitment to the nation. I'm grateful to you for being such an example for all the colleges in the country. Thank you so much. And it is a pleasure to be part of a journey of a person or an institution which has been working so hard to create the very fundamentals required for safety of the people of India. And so once again, grateful to the whole system of LD College, including the administration and the teachers, for really building an institute that is relevant not only to the state but also to the nation. At this juncture, I would like to make only one point before I close this morning, and that point is about teachers. Teachers were, are, and will be the silent backbones of this nation. This backbone should be strong in their subject. This backbone should be intricate in their technical skills. This backbone should be adaptive in their vision, and this backbone should be sensitive in their attitude. And finally, this backbone should remain human in all their approach. Of these 5 major traits that I had mentioned, teachers should possess mandatorily a positive attitude. All skills and knowledge with poor attitude is of no value to the nation. And on the contrary, positive attitude alone with limited skills and knowledge is again of little use. Therefore, all teachers must consider balancing their entire life the 3 items of positive attitude, skill level, and depth of knowledge. Faculty Member Development Program is a humble step to wake up colleagues across India and empower them with the higher levels of skill and knowledge. But as I just said, mere skill and knowledge will not help. The positive attitude will have to be brought by the teachers themselves. And positive attitude depends on your own childhood, your own upbringing, and the affections and the honor and the respect that you have received in your own community. Therefore, at every stage in our lives, we must find excuses to enhance our contributions for the good of others. I wish all the teachers the very best in their career and pray that each of the colleagues will dedicate the rest of their career for the earthquake safety of the nation. Ladies and gentlemen, thank you, and we pray that each of you will engage in this 5-day short course with a sense of learning and with a sense of sharing. Thank you.
Yeah, thank you. Thank you so much, sir, for such kind and motivating words. Now, this brings us to the closure of our inaugural program. We are indebted to all the revered dignitaries for giving us their invaluable time. I would like to extend my heartiest gratification to Professor Dr. CVR Murthy, sir, for accepting our invitation and agree to deliver a session in this program. I am heartily thankful to our principal, Dr. Rajul K. Gajjar ma'am, for her presence and enlightening us with her kind words. I am thankful to Professor Sandeep Sancheti, sir, for his vital presence. Moreover, I am also thankful to all the head of departments of different branches of LD College of Engineering for attending this session. I would like to thank Major Dr. C.S. Sanghvi, sir, the head of Department Applied Mechanics, and all the coordinators as well as faculty members of Applied Mechanics Department for being an integral part in conducting this FDP. Last but never the least, I am grateful to all the participants for attending these sessions, which I firmly believe will assist you in enhancing your knowledge on earthquake safe design and construction practices. Now we shall be beginning with the first session of this 5 days training program. And who can be a better one to start this than our guest of honor himself? Once again, I would like to invite Professor Dr. CVR Murthy, sir, for his keynote address to share his abundant knowledge on the given topic.
Aditya.
Yes, sir.
Murthy sir, I want to take 2 minutes before you start the session. I want to share my experience with Dr. Murthy. I got the opportunity in 2003 to go to IIT Kanpur for a 1 semester program, and we were there, to enjoy the program. And Murthy is, and we assume that there will be no examination. We just go to IIT Kanpur and get some knowledge, and we'll come back. And most of us are believing that there is no exam, but Murthy sir was sure that without exam you will not be sincere. So you have to appear in the exam, and all of us were very tensed. And then our 6 month journey was started. uh, or we are so tense in the first month. Regularly they are asking for the assignments, and then exams, organizing exams. And you see, this is what the culture of IIT Kanpur. And then uh, uh, we have many doubts. So we are saying, Murthy sir, we have doubts. So sir bolte the, oh, come around 2 o'clock. 2 o'clock means what? 2 o'clock in the night. रात को 2 बजे वो हमें बुलाते थे, रात को 2 बजे हम जाते थे उस कैबिन में. वो काफी फ्रेश, मतलब यू वोंट बिलीव कि इतने फ्रेश होते थे 2 बजे रात को. एंड देन हम अपनी क्वेरीज रेज करते थे, वो इज एबल टू आंसर. लेकिन हम भी थोड़े अच्छे थे, वी आर आस्किंग सर्टेन क्वेश्चंस, वो ऑन द स्पॉट जवाब नहीं दे पाते थे, तो बोलते थे कर्नल कल मॉर्निंग में बात करते, कल बात करते. और दूसरे दिन 8 बजे जब लेक्चर होता था, तो उसमें मूर्ति सर इज कमिंग विद अ सॉल्यूशन. नाउ लुक एट द डेडिकेशन. 2 बजे रात को मिले हैं, 8 बजे मॉर्निंग में बिफोर लेक्चर उनका एक्चुअली सॉल्यूशन लेके आना, दैट इज सो द डेडिकेशन. सो यस्टरडे हमने देखा कि लता मंगेशकर हमारे बीच नहीं रही, वो सरस्वती की बहुत बड़ी कृपा थी. ऐसे ही आई टेल यू, सरस्वती जी की कृपा मूर्ति सर के ऊपर बहुत है. और द वे इन विच अर्थक्वेक में जो जितना काम कर रहे हैं वो, आई थिंक दैट इज अमेजिंग. और उनका जो कंट्रीब्यूशन है टू मेक अ सोसाइटी अर्थक्वेक सेफ, इट्स आई थिंक टेल यू रियली वंडरफुल. और हमें ये मौका मिला साल साथ में काम, मतलब उनका गाइडेंस हमें मिलता रहा. इट वाज अमेजिंग अपॉर्चुनिटी. और आप भी आज देखेंगे कि और काफी सब लोग जानते ही होंगे, उसमें सवाल ही नहीं है, सबने सुना होगा. लेकिन आई थिंक दिस इंसिडेंट आई वांट टू शेयर विथ यू, बिकॉज उस दिन से हमारा डेडिकेशन जो बढ़ा पूरी लाइफ में, कि भाई हमें भी कुछ करना है. मूर्ति साहब जैसा नहीं कर पाएंगे, लेकिन कुछ ना कुछ हमें वी वांट टू कंट्रीब्यूट. एंड दैट सेंस comes from December 2003 when we left IIT Kanpur. So Murthy sir, thank you very much for guiding us all the time.
So I am also going to take 1 minute off out of this. I'm going to pick up that huge and wonderful sentence that Dr. Murthy mentioned right now about a teacher, or like as a human being, you can bring in positive attitude from the more and more love and respect that you earn. And that is what I think that every teacher looks out for. The huge, and you can see this is a student talking about his teacher. This was not Colonel Sanvi talking about CVR Murthy. It was about a student to a teacher, how it transpires, and how they have bonded across the years. And I'm sure there are hundreds of thousands of such students who would come out and talk in the same manner about their individual experiences about Dr. Murthy. And in fact, this is a role model that each teacher, each of us inside of us has to aspire to. And of course, each one of you will have that hidden strength which will come out and proliferate. So outside of earthquake engineering, yes, very much important, but also try and look into what Dr. Murthy says, does. There is a huge philosophy that has come, that is built into his entire being over the years that I have observed. Thank you so much, Dr. Murthy. Thank you.
Well, what can I say? I'm choked, but indeed, the early experiences in life will make you. For example, I joined IIT Kanpur, and then the Killari earthquake happened, and we go to the Killari village where everybody is dead. And as we are taking a photograph of a fallen house, somebody from behind suddenly shows up and says, "Do you know that 7 of my faculty members, of my family members, are under the stones?" Then what do you do? What do you do? that's the beginning of your academic career, right? You are answerable to that citizen of India who says 7 of my family members are under the stones. And that is the hair-raising experience of one's lives, which tells you that there is no moment to waste. There is no stone to be left unturned in trying to make safety happen for this country. Come what may, unless you sacrifice personal gain for public good, this life of a teacher has no value and no meaning. And that is where, I'm sure, I'm confident that every one of us goes through such an experience in our lives in our younger days. Only thing is, how much do we remember that experience? How much do we commit ourselves to address that question, that concern, that situation, the challenge that has been posed to you at that early age? And I pray that all teachers will find, something motivating themselves. It has to be from within. CVR Murthy is there outside, but a few years later he'll pass away. Then what will happen to you? No, it has to be from within you. CVR Murthy may be a catalyst for some of you, but he can't be the basis for any one of you. You have to find your own, fire in your belly to live your life, because you have been sent with a special skill, trait, knowledge on this earth with a special purpose, for a special purpose. And you have to find that purpose. Each one of us should enhance our strengths, and eventually you will find the purpose of your life. And I'm hoping that this faculty development program will help faculty members introspect and identify who they are, find out who they are before they do more of the maddening stuff that they are doing today. Okay, with that deep words, let me get to the real life and show you some pictures and ask you to go with me in understanding earthquake safety of India. Yeah. So, in keeping with what I have said this morning in the early moments, I continue with that same how to build earthquake engineering competence in technical teachers of the future. I consider some of us as the teachers of the past, but all those who are attending the program today will be the technical teachers of this nation of the future. And I do recognize that it's a collective responsibility. We can't leave it to you alone, but we'll walk with you up to a certain distance. And then when our station comes, we will get off. But you will have to go on this journey of life and provide safety to the people of India. Today, I will extend my theme of attitude, skill, and knowledge in the subject of earthquake engineering, and ask you to identify what your level on a scale of 10 of positive attitude, skill, and knowledge is, and make sure that by the end of your career, you have a minimum of 6 on all of them, and at least one of them should be hitting close to 9. With that, I will start by saying the role of engineers in disaster management is very crucial. You would know that there are 6 phases in the disaster management cycle, and the engineer comes in very critically in mitigation and to some extent in reconstruction and response. This is where I would say that half of disaster management is purely technical. And so you require very strong engineers who understand disaster management, especially earthquake disaster management in a significant way. And to talk about the importance, relative importance of these items, we are at this spot on the left bottom, and we have to go to the right top. That's our destination. And so one option is that we take the ladder and go up, and that's large work to be done suddenly. And the other option is, of course, that we will go along the dangerous coast and take the vagaries of nature, and then do small little work all the time. And the first is actually response and rehabilitation and reconstruction, while the second path has mitigation in most of it. And when life is much simpler, it becomes preparedness. When the difficult part in all of these you see is mitigation. That is the one that is facing the fury of the nature. And so we need to be strong engineers to be able to face this earthquake disasters with a lot more respect and dignity. Clearly, this is where teachers need to understand that a teacher's life is also like mitigation. You'll have to face the real world every day, all the time, but make other people safe. Like Jagjit Singh says, "Tum haar ke mera jeet amar kar do." That is the life of a teacher, and that is disaster mitigation, and that is earthquake disaster mitigation. So clearly, we have to act now, and that's mitigation. Even though we will have to do a little bit of response and reconstruction later, but if you don't do much mitigation now, you'll do only response and reconstruction. But of course, you'll lose all the lives under those buildings. The impact of what an engineer can do is very clear by the fact that if you let go and don't do disaster mitigation work, then the disaster will get too big that even the nation cannot handle. And that is why you are looking at the critical role of engineers and thereby the critical role of teachers to build the next generation engineers. What is earthquake safety? Earthquake safety involves three segments: people, property, and performance. And it requires three hands to come together. That's academia, industry, and government to make sure that all of these three are protected. But the interesting part in earthquake disaster mitigation or earthquake safety is that if you can protect property, the people and the performance will get protected. That's the interesting part in earthquake safety, that you need to make sure that the property is absolutely earthquake resistant. So talking about disaster mitigation in great detail, there are a large number of activities to be undertaken as part of disaster mitigation. Okay, these can be grouped into three. One which industry will have to participate as the forerunner, one in which government has to participate as forerunner, and one in which academia has to participate as forerunner. This doesn't mean that that is the sole responsibility. For example, full-scale testing is a responsibility of academia, but the significant financial input to build such large-scale facilities is still of the industry. Interestingly, in the subject of earthquake safety, industry in India also means government, because maximum number of public facilities are built by the government insofar as water matters are concerned, transportation matters are concerned, and communication matters are concerned. So in this earthquake disaster mitigation big picture, you will notice that in each of these 15 items, there is a need for the teacher to come up and engage in a deep way, understand each of these subjects and share it with the students in the classroom, be it the fresh graduates or be it continuing education engineers and architects. Each of these items, even though it is on policy matters, requires technical inputs for policies to be made. Policies cannot be made on the desire of individuals, but policies have to be pegged on sound practices, which are actually out of rigorous R&D work done by the teachers of India. In competence, I just mentioned that we need three components here. Interestingly, unlike in the case of the safety, here attitude is the one that is the governing game. And if you have positive attitude, you can learn skill and knowledge over time. But if you don't have positive attitude, you can never find any value to your skill and knowledge. So this is another important facet that you have to understand is, as teachers, if you love human beings, then only this is your career. Otherwise, if you don't have positive attitude, it's important for you to go to the administration's office this evening and resign from the post. There is no need to have teachers who have negative attitude in this country. All teachers should have positive attitude, should love the people and should love the students. Only then you deserve a space in this world of academia. Attitude is a way of thinking or feeling about someone or something. It's about the heart. Skill is the ability to undertake sustained work, and that has to do with the hands. And knowledge is the capacity to interpret available information, and that has to do with the head. So it's the heart, the hand, and the heads that have to come together to make a complete person and to make a complete teacher. Once you are a complete teacher, only then you can make the others who are graduating through you as complete human beings. I'll take one by one the three activities, three elements of competence. One is knowledge, second is skill, and third is attitude. On the knowledge side, earthquake engineering is all about built environment, which is governed by five virtues: safety, functionality, sustainability, aesthetics, and economy. There is no negotiation in the order of the first three. That will be how it will be placed. Only negotiation is on the last two, which is aesthetics and economy. So we want safety to be in the driving seat as far as earthquake safety is concerned, even though you may negotiate with little cost for aesthetics and economy. This is in contrast to the current practice where safety is not in picture, but most of the effort is only in balancing economy, and aesthetics is taking the second seat. It is important for us to recognize that earthquake safety problem is a technical problem, and it can be solved only through ensuring safety of the built environment. And hence, balancing act that we have to do here tells us that earthquake engineering is art in engineering, and it is not mere calculations. To be a good teacher in earthquake engineering, you must have physical intuition. You must know what will deformation, what kind of deformed geometries are generated. You must be able to understand the physics of the mathematics and not just the mathematics of the physics. Most often the textbooks today are dwelling only on the mathematics of the physics, but not on the physics of the mathematics. This is important for us to understand. Every teacher should know load paths, where the load is getting induced and how is it getting carried to the foundation is an important step that each teacher has to understand in the process of sharing the behavior of structures with students. Dynamic characteristics, especially natural periods and natural mode shapes. This is an advice to every teacher, every engineer, every architect that do not design the structure immediately as you are given. You first model the structure and obtain their natural periods and mode shapes and keep it under your pillow for 1 week, and then you will recognize that some of these are not acceptable because you're not able to sleep, and only when you're able to simplify the structure to the extent that only the simplest behavior is governing, then you have gotten the right structure. Please go ahead and analyze and design that structure after that. So you must find the best structure, which is the simplest structure for the people of India, and not find any other complex, complicated, alphabetic shaped structures or Superman type of structures. Those are not sustainable for anyone. One of the important areas in earthquake engineering, which is often not given enough respect in the classrooms, is actually flexibility of the soil strata. It is time for every classroom to dwell on modulus of subgrade reaction and tell them how to model the flexibility of the underlying strata, and only then you will learn that it's not a cantilever bending moment diagram, it's not a cantilever displacement, but it is going to be a very different picture than what we have understood in the past. Every teacher should be able to come up with hand calculations, and only when you are able to do hand calculations that you can say that the number is right or wrong when a student brings a number calculations. You must have strong concepts. If you're talking about earthquake safety, you must know that earthquake is not a force applied in the structure, but it's displacement underneath it. And so you must know displacement loading. You must know strain controlled loading. And so concepts like the chain analogy, through the chain analogy, have to be understood deeply by you first before you share with the others. In here, the old adage that we had, that the strength of a chain is the strength of its weakest link, is now expanded, that the stiffness of a chain is stiffness of its weakest link, strength of a chain is strength of its weakest link, as well as ductility of a chain is the ductility of its weakest link. This is what we would like you to understand and then share it with the students. You also need to know damage. Many a time there are different models given by various researchers on damage, but till date there is no satisfactory model for quantifying damage. And this is what we would like to urge you, that please do recognize that damage quantification is still the most challenging and the most unfinished activities in the entire earthquake engineering gamut. One area which has not been addressed in this nation, and we have built large number of structures without respect for human beings, is actually the use of untested technologies that were bought from other countries and used without respect for the necessary standards and without respect for necessary experimental verification. Examples of those are precast buildings, pre-engineered buildings, and pre-stressed flat slab buildings. Anyone who is building any more of this today is actually causing harm to the nation, because we don't have standards for allowing you to use any of these indiscriminately, at least the way they are being practiced today. There is a need for developing full-scale test facilities, and I'm very happy at least the nation has two such facilities, one at MNIT Jaipur and another at IIT Kanpur, to undertake full-scale testing essential for verifying new technologies. No new technology should be approved by any organization by mere hand calculations without doing full-scale testing of that, because full-scale testing is required because the nonlinearities are different when you have different scales of structures. And since you want to know the actual nonlinearities appearing in future, you should do full-scale testing. Yes, they are expensive. Yes, they can only be built in limited numbers. All having said and done, for 140 crores of people of India, we need more than just two full-scale testing facilities. There is also a large number of structural systems that have performed very poorly in the past earthquakes, and it's time to stop them. Unreinforced masonry in seismic areas, open ground story buildings across the country, and flat slab buildings that have caused havoc in the past 20 years. We should not permit any of these to have poor performance. But the question is, as teachers, do we know this? As teachers, are we convinced about this? If not, you better spend some time and understand that these are such fundamental issues that are causing harm to the nation, that you as a teacher, you as a torchbearer, is supposed to guide the nation. And are you doing that enough in your classrooms? If we sit quietly, the nation will keep growing, and we keep growing to twice its size by 2050. 140 crores might become 280 crores or 260 crores if the nation is very active otherwise and not in earthquake safety. This is a threat for us as engineers. Unless we have sound practices, we will not be able to sustain this sudden explosion of the infrastructure or the urbanization that we are doing in the next 20-30 years. For understanding infrastructure development or urbanization, you need to understand hazards. Very clearly, hazards are of two types, non-random and random. And in general, we talk about Gaussian distribution, but in the case of random loads, it is Poisson distribution. And so while we classify loads into different categories, earthquake definitely comes under the second category. And so the Poisson distribution tells us that there is something more that we need to understand than normal loads. Even the normal loads, where we say 95% of the cases this load is not exceeded, is not actually assured in all cases. And that is the worry that we have, that many a time we are saying design loads are characteristic loads, but not so. It is not so. We need to be very careful in the road ahead to make the correct statements so that the people will not get a false impression that this is a known quantity. Talking about earthquake loads, we have to play with probability here. It's a matter of taking chance. If you don't want to take chance, you will design for the full P ground acceleration that the area is likely to be shaken by. So, but if you want to take a chance, then you will say for normal buildings, I would like to reduce the design force. And for important structures like hospitals, I will not take so much of a chance. And for critical facilities like transport, water, power, communication, gas, I will not allow any significant damage. And then in special structures like dams and MPPs, I will not allow any damage. If that is the kind of philosophy that you would like to take, then clearly we are seeing that we will have to play with the probability. Do we know how much we have to design for? At least based on the design codes. If you design a structure by the design codes that we have right now, do we know what is the probability of exceedance? This work has not been undertaken in the country yet. And I pray that we should have at least some faculty members going forward in understanding the matter of the hazard being quantified differently with the role of annual probability of exceedance coming into picture. You are familiar that Andaman Nicobars, Gujarat and the Himalayas are the main areas where we'll get strong shaking. Of course, there are surprise earthquakes in the Indian plate, but this is the known danger and we have to protect ourselves from that. 200 kilometers from these locations are still under the radar of damageability, which means that if you have an earthquake in Bhuj and Ahmedabad is 225 kilometers away, you will have damage there. And if you have an earthquake in Himalayas, and if any of the towns like Delhi are only 200 kilometers away, radial distance, then you should be able to prepare yourself for such damage. This is where the teachers of India have to tell the truth and prepare the people, prepare the engineers, prepare the practicing engineers to actually quantify hazard more realistically and design for the same. If you go close to the faults, you will notice that the fault motion is going to be such that you will see a outward motion and then coming in. And this motion here shows you that along the fault parallel direction, we get a residual slip, and along the fault normal direction, we don't get a residual slip. The interesting part is the velocity along the fault parallel and fault normal directions can be very large, 1 meter per second, 1.5 meter per second, and 0.75 meter per second. Such large velocities usually are detrimental to structures that have localized flexibilities, like the open ground story building. So India has a very peculiar situation. The Jambu Dweep, the major island, came in and then collided with Eurasia, and the ocean bottom material became the landmass of the North India, which is the Indo-Gangetic Plain. And we have not yet introduced this in our design practice, right? The big picture is very crucial for us to undertake and make sure that we are able to use the correct spectra for acceleration and displacement in the design of new structures and assessment of existing structures. Talking about vulnerability, if you look at three of the hazards, wind, flood, and earthquake, and you'll notice that while wind has a tendency to take the structures upwards, water has a tendency to blow it from the side, and earthquake is move it from the bottom. So in the case of wind, you are looking at the elements going upwards. In the case of water, it will be toppled, and in the case of earthquake, it will be shattered. What is the meaning of all of these? That we are looking at these actions to be resisted, and one of the simplest points that we need is large mass in the first two cases, but small mass in the third case. This means that at the same location, if we are faced with wind and earthquake, the requirements are contrasting. And that is where the art in engineering comes when you're looking at earthquake engineering. And teachers should be able to do this balancing act. And for that balancing act, you must understand that between wind and earthquake, what is the big difference? Wind behavior is largely elastic, but earthquake behavior is largely inelastic. Wind is actually a force loading, and earthquake is actually a displacement loading. And this is where the big difference has to come in by the people of the academia who are steering the agenda, the faculty members, that do you know the difference between wind behavior and earthquake behavior? And this is the point where most of the nation is failing today, that all occasions I have noticed teachers keep saying earthquake is a force, earthquake is a force, earthquake is a force. It's time for us to shift our heads from the vertical axis to the horizontal axis, from force loading to displacement loading when we talk about earthquake shaking. Displacement loading, whether you like it or not, if you make the structure flexible or you make the structure stiff, if you make the structure weak or you make the structure strong, the earthquake is going to impose that much of displacement, and your responsibility as the teacher is to teach students how to make sure that the structure has at least that much displacement capacity. The demand is fixed by the nature, and it's capacity that we have to teach our students how to create that capacity in the structure through appropriate analysis, design, detailing, and construction and maintenance. So there is a big gap in the knowledge that we are talking about at this juncture, in the way the textbooks are written, in the way the teaching is practiced in the colleges across the country. Exposure is another important area. You must understand that if there's a building that is likely to collapse and nobody is living in that, there is no exposure, zero exposure. For example, if you have a open, sandy dunes of Rajasthan and there's a big earthquake, how does it matter? There is nobody living there. So there is zero risk. Exposure is very important to understand. How many people are exposed to that structure, how many properties, how much of downtime, and how much of business continuity is lost by this exposure is the key question that risk is asking. And so there is human risk, property risk, financial risk, and business risk. You might say, what is this new word suddenly you threw on us, which is called risk? Well, risk has three components: hazard, vulnerability, and exposure. Hazard is based on nature, and earthquake science helps you understand and estimate it, not calculate. Please only estimate it. Vulnerability is through earthquake engineering. Again, earthquake engineering helps you estimate the capacity of the structures. So hazard is the demand, vulnerability is the capacity, and the third one, the bylaws will tell you how many people are going to live in that. And so the convolution of all of these three is actually risk for us. What you'll notice in all of this, if vulnerability is zero, risk is zero. Hazard is never zero. Exposure is never zero. So the entire game of all the teachers of India should be to make sure vulnerability is reduced as much as possible. And that is the key essence of the classroom education for all the teachers who are in the subject of earthquake resistant design or structural design, including earthquake safety. So when you talk about risk, you can have this situation on the left-hand side, which is the current situation, that we are actually going to see a lot of losses of lives because we have not improved our vulnerability. But if you improve your vulnerability of the structures, then you can reduce the losses to an extreme case of the intolerant and the probable extreme, the big earthquake that is likely to come. That is where I think we need to push. We need to reduce our losses to the extent possible. One word that is coming in every discussion these days naggingly is multi-hazard. Let's understand multi-hazard a little carefully. Multi-hazard resistant design is involving two parts. One is the defiant design for all the force loading, and one is compliant design for the displacement loading. The force loads and displacement loads we just showed you are the classical loads that we all know of are sitting on the force side, and on the displacement side, on the prominent loads that sits there is earthquake loading. And very clearly, might is not always right. And that is the game that we want to understand, that when it comes to seismic design, you can't say, I will make massive structures. If you make massive structures, F is equal to MA, M is large, A is known. So you are actually increasing the force, but you have used brittle material like the ones that are seen in the picture here. You have used masonry, and so masonry has very weak strength. So resistance is less, demand is more, and collapse is imminent. Therefore, it's important that you recognize that nature is always right and that you have to comply with nature. And in earthquake resistant design, you'll do compliant design and not defiant design. There's another major lacuna in today's education practice in many countries. In India, we have not started earthquake engineering education in a significant way. So we are at the beginning stage. So we can make this correction. What is that correction? Today we know the material, we design the section, we draw the members, and then we detail them and go ahead and construct. But we don't know what is the behavior of the structure and where will damage accrue. That is where the crisis is. So we're doing the forward loop, but not doing the reverse loop. As a consequence, we are not able to guarantee to the people of India that the building that you have designed is actually going to stand or collapse during the design earthquake that is likely to come up. So it's a game of uncertainty we are playing, which is not acceptable. Faculty members should empower students, graduates, to be able to design structures with confidence. And that can happen only if we have a closed loop design method. And so no student should leave the portals of the institute without knowing the full closed loop design method. Well, talking about design, what are you designing for? 7 virtues is what you have to ensure in your structures. What are the 7 virtues? One is configuration. Second is adequate stiffness, sufficient strength, required ductility, the design deformability that is imposed on the structure should be resisted by appropriate deformability capacity, and then the collapse mechanism should be acceptable, and then there should be enough energy absorption by the structure. If all the good things, all these 7 good things happen, you have successfully designed an earthquake resistant structure. So as teachers, we must know the difference between each of these 7 items. We must know the implications of one on the other, and we must know how to quantify each of them, and we must share with the students so that when they go out, they are conscious of all the 7 virtues of earthquake resistant construction. New design methods also need to be developed here alongside. What we are looking for is that there are 4 levels of design: the stiffness based design, strength based design, deformation based design, and energy based design. The strength based design was the practice in the early years, where the stiffness based design was the practice in early years, and it has been discontinued now, because this is what I showed you, that heavy masonry structures defined to design was not the method for safety during earthquakes. So when you come to compliant design, you have to allow damage, and you are, in most cases, you can do dissipation devices also an alternate measure. And strength-based design is what we are currently practicing, but in the road ahead, we are looking at deformation-based design, which is currently under development, and energy-based design, which is the future activity. In deformation-based design, you need to estimate deformability, which means instead of giving you an acceleration spectrum, we have to give you a displacement spectrum. Codes also have to change for this, and we pray that in the road ahead, some of these changes will also be coming in a more emphatic way. But you can't wait for the codes. Teachers should be 2 steps ahead of the national standards. So it's time for the teachers to learn displacement-based design, deformation-based design, energy-based design, and build them in the minds of the students, so that when they really happen, there is no surprise in those engineers. The Indian standard, 2,000 of them just related to buildings, 400 are related to safety out of these 2,000, and only 10 are related to earthquake safety. And this is the interesting part, that we have only a limited number of standards for 25 plus types of structures that we have, and it is time for us to expand this and build the remaining standards. Teachers have to play a significant role in trying to build the standards in India, because most practicing engineers are able to give limited time. Somebody has to sit and create these draft documents so that the practicing engineers can give their best inputs. This is where another important facet of India's safety lies, and teachers have to come in a significant way. Professionals and academics together alone can build the safe design standards. One needs to understand technology. The classroom, Indian Institute of Technology, that's the title of our institute, but we teach engineering. We don't teach technology in the classrooms. We teach component design. We don't teach system design. For example, if you want to teach technology, there should be holistic competence. So the teacher himself or herself should have holistic competence in that area. I'll give you one example, that when you talk about the safety of dams, you have to talk about field tests, you have to talk about analytical studies, you have to talk about laboratory tests, right? And as of now, the subject of field test and laboratory test is not there. Only analytical studies are in focus in limited locations, that too limited individuals in the country. And in that analytical work also, while the extreme left is 1960s knowledge, the today's 2020s knowledge on the extreme right, the 3 elements are still to bring in, coming into the practice in the country. So we are still striking 2 stones to get fire when the world has gone so much forward. This is time for us to build more teachers who are able to have competence in one area. This is also an occasion for me to tell you that when we joined employment, there were very limited number of people who are formally trained in the subject of earthquake engineering. But today that's not the story. Today, each of you has the luxury to actually specialize in a single area. When I say you specialize in a single area, that is from the research point of view. But from teaching point of view, you must understand that the design of all different structures will be different. For example, design of buildings and design of bridges are exactly contrasting to each other. In buildings, you say horizontal members should be damaged. In bridges, you say vertical members should be damaged. You may be shocked, but that's the reality. So this is the game that I'm saying, that you need to know design of all structures, but when it comes to research, please spend your career in only one structure that is of interest to you. This luxury we did not have when we started, but this luxury you have today, thanks to all the hard work done by many individuals to upgrade themselves and become competent teachers to support the needs of the nation. Another area that requires special attention from last 50 years, we have increased the cost of the non-structural elements, and that cost has gone from 5% to 90%, which means that safety of non-structural elements is also crucial for the safety of the nation. We are looking at large stock of buildings, 32 crore buildings that are already there, out of which 80% is sitting in seismic zones 3, 4 and 5, which means about 25 crore buildings are sitting in seismic zones 3, 4 and 5, which need to be retrofit because they were not designed as per any regulation, and that is where the game is. So we have all the new structures to be built safe and all the existing structures to be examined, and if they are unsafe, they need to be retrofitted or replaced. This is the game. Replacement is very expensive. Retrofit is the future of this nation. Any teacher wants to specialize in that, you will make life enjoyable for yourself. And especially, we need urgent requirement for critical structures that are of strategic importance, lifeline structures related to health, water, power, fuel, transport, communication and food, school and office buildings that require governance continuity and essential services to happen, and residential buildings, especially of those critical officers like the district magistrate and so on. Assessment, one area, assessment of existing structures that has to grow. There are a lot of notions, and the whole nation is plagued by this vulgar word called rapid visual survey. And they think that rapid visual survey will tell us whether the individual building is safe or not. This is not true. And that is where a depth of knowledge is required by faculty members to tell that the first quantitative level at which you can talk about an individual structure is the simple quantitative assessment. And only when you pass this that you can say that you have at least some basic safety. But the final confirmation will come from detailed quantitative assessment. These 4 levels of assessments are such that, of course, the first one will take the least time and least rigor, second a little higher, third is higher, and fourth is even higher. So if you take about 1,000 structures, put them through the filter number 1, 100 will go to number 2, out of that 10 will go to number 3, out of that 1 will go to number 4. Imagine 25 crore houses have to be assessed. How many man hours and man years are required? The number of people are not available in India. So we have to prioritize the retrofit activity to a limited number of structures, and as far as possible replace some of the older ones that do not meet the national standards as of today. While we are talking about retrofit, a lot of quacks in the market who are trying to sell away products which are not relevant to safety. Retrofitting, rehabilitation, repair are 3 distinct words. Retrofit involves structure capacity to be enhanced. Rehabilitation involves functional use to be altered, and repair involves visual improvements to be made in the structure. Structure capacity in turn has restoration to an original level after it is damaged, or upgradation from the existing level to a higher level, or when you remodel, which involves functional use change as well as in upgradation, you will be able to see the structure capacities enhanced. In summary, repair is not retrofit. It is far away from retrofit. If anybody says I have repaired the building and it is now safe for earthquakes, I think it is time for you to give a clean understanding of what is repair and what is retrofit to that person, and also leave that room without drinking tea. The process of retrofit is adequately rehearsed and highlighted in international documents. There's enough clarity on that subject for us to get started right away. So the bottom line today is all new structures should be safe, and that will happen through peer review of designs. technologies with R&D backing and type designs if they are tested full scale. Existing structures should be assessed, and you need nonlinear analysis, and you need to strengthen them through retrofit measures, and this cannot happen whole hog. You have to start with pilot projects. And finally, the third level, you need competent engineers, and that only teachers can create. Sound appointment should be made in the teachers itself. We cannot have weak-hearted teachers, we cannot have negative attitude teachers, so that they can train graduate engineers, so that they can undertake continuing education, so that tomorrow when licensing of engineers start, they start preparing teachers to preparing the engineers to become licensed through appropriate body of knowledge. So in the current status, 80% of the knowledge that is available internationally can be employed in the Indian condition. Only 15% needs to be adapted through some modification, and the remaining 5% is where we have to do research. That is the game, that is the current status in the country. So we need to do a lot of technical education, continuing education, skill enhancement, sensitization, awareness. In this, teachers will find center space. In research, hazard assessment, full-scale testing, seismic design, seismic retrofitting Indian standards, teachers will find center space. And in development, bylaws, licensing of engineers, peer review, structural safety audit, risk indexing, teachers will find center space. On the whole, Indian teachers can save this nation through their hard work and through their dedication to the pointed questions that the nation is asking us, that can you help us in fixing these items? You cannot say that I will wait for a perfect situation and then I'll start. That's not possible. You have to make an imperfect start with the available knowledge and then slowly do the other items that we discussed. Second, I'll go to the skills part. One of the important skills that needs to be introduced urgently in every college in the country, at the master's level at least, is nonlinear analysis, which involves both geometric as well as material nonlinearity. Without this, you cannot understand earthquake behavior. Forget it. If you are not willing to do nonlinear analysis, leave earthquake engineering. Programming is one skill. Programming is not using technical software. Programming is doing the calculations yourself. And for that, you have to be very strong in hand calculations. So while you'll continue to use earthquake engineering software for the student undergraduate level, but for the master's level, you must write yourself a 6,000 line program so that you know what are the background activities that one needs to undertake when you do nonlinear analysis. One needs to know sensors and instrumentation, because in the road ahead, you will see health monitoring, load testing, ambient vibration, forced vibration, and elastic response becoming the most important activities for teachers to engage in. Because you will require dynamic characteristics, you will require to understand the behavior of the structure, you will require to know what is the level of load imposed and what is the response given by the structure. This will lead you to a large amount of data. So you need to know mathematics, you need to know statistics, and you need to know probability. As teachers, if you don't know these three, you cannot do this part of it, which is the main heart of safety of the structures. You also need to understand that civil engineering is not mere, calculations and constructions. It is also about trying to engage with electrical engineers and create nonlinear analysis chips which can enhance your structural analysis in a quick way. Building information modeling can help you in trying to resolve many of the crises that you are facing today. These are some basic skills that I am trying to mention here, but there are many more. For want of time, I'm dropping those. Third one is positive attitude. There's a spectrum of structures. They behave differently depending on the geotechnical conditions and the proximity to the seismic hazard, the seismic faults, and we need regulations. And these regulations have to be sensitive to the multi-dimensional, multi-speciality aspects of hazard, vulnerability, and exposure. They require different levels of rigor. The structures which are on the right hand side, nuclear power plants and dams, require much higher level of rigor than the buildings that we have on the extreme left side, the residences that we have on the extreme left side. How do we address that? That you can address through competence, which is beginning from childhood to school days, to college, to employment, to retirement. This is a 5-cycle competence development that is continuing to happen in our lifetime. If you are unconscious, you will miss all these competence development cycles. If you are conscious, you can enhance your capacity in each of these stages and make sure that you are valuable. Like Shankaracharya says, Paropakaram idham shariram. For the good of others is this body. So competence development today is required in the nation for earthquake safety, and we have 94% of the people as workers and supervisors, and another 6% only in the form of engineers and managers. Parallel work is required on all of them. Some teachers can focus on training artisans, some teachers can focus on training supervisors, some teachers should focus on training engineers, and some of the teachers on the training of managers. When I say managers, technical managers. But competence building is essential in this nation. What is competence building? Basically, if you know your mistakes, then you will cover those mistakes and make sure that next time that mistake doesn't cost you at all. And this is capacity development that we are talking about. We hope that teachers will recognize that you are actually helping the students fill the pots till the top, so that there will be something that they can offer others when they get into their careers. Word that's commonly coming up today is resilience, and there is an event and suddenly we are incapacitated. If we have not done anything in life and then later somebody kicks us on our back, we try to do something, we're still not making any progress. We haven't done anything so far, but after the event we start doing preparedness, still you're below water. But if you have been doing mitigation and preparedness after the earthquake, you will come back above the baseline, and then you can say that you have made contribution to the nation. So mitigation is the differentiator, and the recovery time depends on whether you have done mitigation or not. If you don't do mitigation, there is no recovery time, it's infinity. So the key is that the effect of earlier mitigation efforts is what will lead you to raising this point higher and higher, so that eventually earthquake should not cause such a setback that you are incapacitated permanently. This is what the nation requires from us, and as teachers, we have to provide this to the nation. What are the things that we can do as teachers? We have to develop licensed engineers, and the licensed engineers are those who can dynamically update their knowledge and demonstrate the same through passing of examinations. This is a worldwide practice. So first, the teachers should themselves become licensed, and second, they can then help structural engineers become licensed. The important point that world is asking is that when the engineers design structures in other countries, can they do it? Because the standards are different and the quality of the rigor, level of rigor is different in different countries. Today, very few structures of us are going through the audit, and time ahead, we want all 100% of our structures to be put through the complete audit before they are approved for construction. This effort requires teachers, and you will be the one who will create that. Third-party peer review is where the game is. The building owner employs 4 sets of people to undertake the development of a structure, and that set is called the quality control group, because he's taken those who have done good education and employed them to do this work. That's not sufficient. They are human beings. They can make mistakes. So we need another set of people who will oversee their work, and that is called the quality assurance group. This quality assurance group is independently reporting to the building owner as well as interacting with the first set of quality control group. And this is where the first, second, and third parties are. So third party peer review is the future of this nation. So to prepare all these competent hands, the teachers have to come in a significant way. In summary, you can see that in the whole professional life, we have 3 errors that we make. They are error of intention, error of execution, and error of concept. Now what you might say is that these 3 errors, how do we solve these 3 errors? The first most dangerous one, error of intention, can be resolved through a law that will tell you that this is not acceptable. The second, on error of execution, can be resolved with the help of techno-legal regime, which means you do third-party peer review of professional civil engineering services based on building codes and bylaws by licensed engineers. And the third one is concept, where capacity development through teachers who are themselves competent will be the future of this nation. If capacity development doesn't happen, the top two don't happen. And hence, if India has to become safe, teachers have to become competent. Teachers should do technical education, which is absolutely as required for the nation's earthquake safety. 360-degree education is what we must offer to the students: analysis, behavior, design, construction, maintenance, and retrofit. If a teacher by the end of the career is able to do all these, then the teacher has lived a fulfilled life and can share with the students a very thunderous experience of going through technical education. There's no place for complacence. It's time for us to understand that competence is where the game is, and positive attitude will come and play the most important role. And I'll stop here by saying a few words that system education and not component education is the first major shift that we have to do in our own effort. Second, we must recognize the importance of earthquake engineering. In fact, two of the noted professors wrote in their book, if a civil engineer is to acquire fruitful experience in a brief span of time, expose him to the concepts of earthquake engineering, no matter if he is later not to work in earthquake country. This tells us that the completeness of an engineer, the completeness of a teacher can happen only if they learn earthquake engineering as a displacement loading and go through damageability states and estimation of damage. So in summary, we need to understand the demand, earthquake demand, and we need to ensure earthquake capacity. Both are important. India's growth will keep dominating us, but the new earthquake engineers that we require are supposed to have a certain set of traits. They need to develop new curriculum. As Madam Rajul Gajar just said, it's challenging to do the balancing task, but we have to continue to crusade. Non-linear analysis should become mandatory part of education. New design methods have to be brought out by teachers. New pedagogy, a way of teaching. We need to mix animation as well as pictures together to teach effectively. We need to go into nonlinear programming through the hardware. We need to undertake full-scale testing, prepare manuals of good practice, and engage in standards of practice, development of standards of practice. We'll have to do a lot of assessment of existing structures and retrofit them. Continuing education of practicing architects and engineers. Risk assessment at a national level. Type designs through full-scale testing. Pilot projects for retrofit and enforcement of a techno-legal regime is all where the new earthquake engineers are going to be, and where the teachers have to be 2 steps ahead of the engineers. Once again, you will have to learn to work with industry, academia, and government, and only then you are going to make competent engineers, and only then you are going to be competent as teachers. Wisdom is, do not make the known mistakes, right? We are having manpower shortage, land use issues, material issues, and technology issues today, and compliance issues. Let's drop each item one by one. In all of this, teachers will have to tick the first item on the top, which is manpower issue. And that is where I invite all teachers to dedicate themselves to the burning question of the nation, is to build competent hands that can build the nation in the road ahead. Right? It's a lifelong crusade to build competence. You bring the children out of their dream world into the ideal world in the school and get them to transit to the transition world in college, and hit them with the real world during employment, and finally, as they retire, they will learn the true world. And this transition can happen only if they have had successful experiences interacting with the whole gamut of people. As I talked about this, do not forget that Safety has no shortcuts, right? You have to go through the long route, and only then you will see that your entire life as a teacher will be fulfilling, right? The five elements of nature will continue their fury on us, but we have to do the built environment with minimal interventions in nature, with natural materials as much as possible, with disaster resilient features in them, and also respect nature and merge with nature. We need to have big picture, we need to have a sense of geometry, we need to have the imagination, we need the analytical capabilities, the design acumen, the nerves for execution, and above all, common sense to undertake any civil engineering activity. Ladies and gentlemen, I must stop with this last slide, which is safety. Safety has to go to the driving seat. I'll stop here by saying structural engineering is art in engineering, earthquake engineering is art in engineering. Every engineering that is related to earthquake engineering is art, because this is where your right brain has to come into picture, and you will have to bring out the best from yourself and give the best to the nation, and nothing but the best. It's time to get into action. The conditions are tough and it's hard work, but important thing is there won't be anybody telling you what to do. Let others follow you, but you have to brave to walk out first and help others build this nation strongly. If that's your dream of earthquake safety of a built environment in India, then join us in this crusade to make India safer in the years ahead. That's the only way that from untruth to truth, from darkness to light, and from life to eternity, we will build this nation, and we need to do it together as a collective set. I'll stop here by thanking the LD College, especially Professor Rajal Gajjar and Professor C.S. Sangvi for making sure that I'm here today and able to share with you my experiences. Ladies and gentlemen, thank you for your time and attention. Jai Hind.
Thank you so much, sir. However, any amount of thanks I will say will not be adequate for the vast ocean of knowledge and experience we have shared with us. It was quite an interactive, informative, and detailed session, but yet delivered in such a lucid manner that every participant would have thoroughly enjoyed and gained a lot from this. The topics you encompassed in your session, like the earthquake disaster mitigation techniques, its importance, the response, rehabilitation, and reconstruction, the bifurcation of role for academia, industry, as well as the government for mitigating disasters. The special slide which I noticed for the attitude, skill, and knowledge, the concept of heart, hand, and head was quite fascinating, sir. The stress on damage identification, the difference between the wind and earthquake loading, as well as the points you emphasized for grooming the faculties and students towards studying earthquake, like holistic understanding in one area, appropriate utilization of technology to be competent engineers, the importance of non-linear analysis in the modern time, the resilience, and above the captivating and the interesting presentation, the slides you prepared were absolutely treat to all the participants. So I extend my gratitude and thanks to Dr. Murthy sir for delivering such a great session. If, being an undergraduate student, I can say that I have learned a lot from this session. I can guarantee that all those learned faculty members and all the participants from masters are sitting here would have definitely gained a lot from this session. Thank you so much, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
It was, sir, it was really wonderful. And you are given a principle: ask yourself, ask attitude, skill, and knowledge.
That's
So
right.
like we are keep on asking ourselves, and we try to improve.
Yes, ask yourself if you're competent. Ask
Yeah,
yourself if you're
yeah,
competent.
yeah.
True.
Now the session is open for the questions. If you have any questions, you can raise your hand, and you can ask. You can take the advantage of Murthy sir knowledge, and please raise your hand and ask question, please.
Just a small note, if all the participants can see the option of raising hand in front of, beside the chat option, you can raise, okay.
Yeah, Mr. Lokesh, can you switch on your video?
Sir, are you able to hear me, sir?
I cannot see your video.
Actually, the video icon has been disabled.
Oh, okay, okay. Then go ahead and ask a question.
Yes, sir. Sir, can you elaborate on the energy point among the 7 points that has to be considered?
7 virtues, yes.
Yes,
The
sir.
earthquake will feed energy to the at the base of the structure. If the structure doesn't absorb that energy, the earthquake is over and the structure will keep shaking because there's only kinetic energy that it can convert the earthquake energy into and keep going back and forth. Fortunately for us, there is little damping, structural damping, and so in about 3 days or 5 days, that damping will eat away that earthquake energy. So for 4 or 5 days, you will be shaken. Like James Bond says, you'll be shaken but not stirred. If your design is earthquake resistant, you will not be stirred, but if your design is not earthquake resistant, you will be stirred also. So it's important to absorb that energy. Now you can do that absorption of energy through the elements, structural elements, or through base isolation devices, or through energy dissipation devices. Choice is yours, but you have to absorb it.
Yes, sir. Thank you, sir. I have one more question, sir. You had mentioned that earthquake point of view, we need a smaller mass, and from other point of views, we need a heavier thing, like for example, wind or water from the side. What would be the ideal way to find the right balance in between, sir? Is there any calculation for that, or how is it done?
There's no magic in this game. Experience. When you're 30 years older as an engineer, you will learn that this balance will come through appropriate proportioning. There is no fixed answer depending on the structure, depending on the zone of cyclone or the wind versus the earthquake. You will find appropriate proportioning becoming relevant in that town.
Okay, sir. Thank you, sir.
Sure. Yeah, looks like the teachers have been taught not to ask questions by their teachers, and that is why they are not asking questions. So one of one of the issues about teachers is that if you don't ask questions and you don't answer the questions, you will not allow the students to ask questions, and you will never answer questions. That means pathanam, mananam, chintanam, sankirtanam. If you don't speak, you are not learning also. So it's important for you to ask questions and help students ask questions. Okay, thank you, Chetan bhai. Looks like they're all shy of asking questions. We can stop. Yeah, I'll come back anyway with 2 more lectures, so at that time we will talk more.
Yeah. Okay. Thank you very much, sir. And I think all of us have enjoyed a lot, but with the enjoyment, our responsibility will definitely increase. And we know that all of us have to contribute, and if we don't contribute, then we are not able to make earthquake safe society. So we understand that part, and I think we understand the message what you have delivered today. We keep remember this message, and we try our best to make the society earthquake safe, sir. We try to contribute as much as possible. Thank you, sir.
Thank you so much.
Thank you, sir. Thank you once again. Thank you so much. Now I would like to conclude this session. But before going, there are a few set of instructions which I would like to pass on to all the participants. Our next session will start at 12 p.m. sharp, and it will be delivered by Major Dr. C.S. Sanghvi, sir, on the concept of ERD of RC structures learned from earthquake. For that, I would request all the participants to join through the unique MS Team ID they have been provided with, because if then only they will be marked with their attendance. If they join as a guest, there will be that won't be a proper way of joining in this team ID. So it is requested to join with the MS Team unique ID given to you. Moreover, there is a small announcement that we will be having a quiz at the end of these 5 days. So please take a note of this. In every session, the question will be based on all the sessions delivered in this 5 days program. The link for joining of the second session will be provided to you in the WhatsApp group, as well as you will get in the MS Team calendars. So I request you to be join on time at 12 p.m. sharp. Thank you.
And Aditya, it is very difficult to take a session after Murthy sir's session. So it is it's very challenging.
No. So next time I should speak at the end, not at the Okay. Okay. Thank you again. Thank you.
Yes.
Okay. Thank you, sir. Thank you.
Yeah.